Question number 2, page 147, reads, a 72 kilogram sled is pulled forward from rest by a snowmobile and accelerates at a rate of 2 meters per second squared forward for 5 seconds. The force of friction acting on the sled is 120 newtons backwards. The total mass of the snowmobile and its driver is 450 kilograms. The drag force acting on the snowmobile is 540 newtons backwards. Part A, determine the tension in the rope. Before we begin, we're going to let right be positive. So we'll write this statement. In fact, it's forward as indicated in the question. Let forward be positive. And we can start by determining the tension in this rope here. So we actually want to find the force of tension. In order to do so, I'm going to draw a free body diagram of the sled. We know that the sled is being pulled by this rope. And we know that there is friction that exists as well. Friction is opposing motion, so it's in the backward direction. They tell us in the question the magnitude of the friction. They said it's 120 newtons in the backwards direction. We always approach Newton's second law problems by following the same 2 steps. The first step is to write a statement listing all of the forces acting on the object using plus or minus signs to indicate the directions. So the net force acting on this object is equal to force of tension plus the force of tension and minus the force of friction. Plus indicating forwards and minus indicating backwards. The second step is to replace this term here, F net, with the expression MA. So we say MA is equal to plus the force of tension minus the force of friction. And we're going to rearrange this equation and solve for the force of tension. So using our algebra skills, we say tension is equal to MA, and when we bring over this force of friction, its sign will change, so it'll go from negative to positive. So we say plus the force of friction. And we can sub and solve. At this point here, we know the mass of this sled is 72 kilograms. We know the acceleration from the question is positive 2.0 meters per second squared, and friction is 120 newtons. If we punch this into our calculators, we end up with positive 260 newtons. So we can say that the force of tension is equal to 260 newtons forward. In part B, they want us to find the force applied by the snowmobile to pull the sled forward. The question tells us that the snowmobile experiences a drag force which opposes the motion, and the drag force is 540 newtons backwards. So the drag is a form of friction. We also know that there is some resistance due to the force of tension from pulling the sled. And we know the magnitude of this tension from part A. We calculated it to be 260 newtons in the backward direction. So to find the applied force, we're going to take the same steps. We're going to use the F net equals and list all of the forces acting on this object using plus or minus signs to indicate the direction. So we know the net force is equal to plus the applied force, it's forward, minus the drag force, and minus the force of tension. Second step we take for solving all of these problems is to replace the term F net with the expression MA. So from here, we can rearrange this equation and solve for the applied force. So the applied force is equal to MA, and when we bring these two guys over the equal sign, their signs change. So they'll become positive, so it's plus the drag force plus the force of tension. So let's sub and solve. Force applied is equal to 450 kilograms times 2 meters per second squared plus 540 newtons plus 260 newtons. If you punch this into your calculator, you should get 1700 newtons, positive 1700 newtons, and we can make a statement that says the applied force is equal to 1700 newtons forward.